I'm using Scikit-Learn's SpectralBiclustering algorithm to find groups of genes and samples that behave similarly in a gene expression dataset. It's like finding communities within a network of genes and samples. I'm telling the algorithm that I expect 5 groups of genes and 3 groups of samples. Think of it like organizing 100 genes into 5 boxes and 50 samples into 3 boxes, based on how their expression levels correlate. This is the output of the algorithm. It holds the answer to the quiz. It tells me which genes belong to which gene group and which samples belong to which sample group. I have a dataset with measurements of the expression level of 100 genes in 50 different samples. Each measurement gives a value reflecting the activity level of a specific gene in a given sample. This statement is correct. The Biclusters attribute will show which genes and samples are in each identified group, bicluster. It's like a membership list for each box. This is incorrect. The structure of Biclusters isn't a simple gene cluster X sample cluster matrix. It's a more complex representation of group membership, showing which genes and samples fall into each group. That's also incorrect. While the algorithm internally uses permutations to find the best grouping, the Biclusters attribute doesn't directly store the permutations themselves. It stores the information about which data points are grouped together. This is wrong. The shape of Biclusters doesn't directly correspond to the number of clusters, 5 gene clusters, 3 sample clusters. The shape will reflect the way the algorithm internally represents cluster memberships. It's not that simple. I'm analyzing gene expression data using a technique called SpectralBiclustering. This method helps me find groups of genes and samples that behave similarly. My data includes information on 100 genes and their expression levels in 50 different samples. Think of it as a 100 by 50 matrix. I'm using Scikit-Learn's SpectralBiclustering algorithm, and I've just finished fitting it to my dataset. This means the algorithm has processed the data and found the biclusters. This statement is incorrect. The shape of biclusters doesn't directly match the number of gene and sample clusters, 5 and 3. Biclusters holds more information than just the number of clusters. It tells me which genes and samples belong to each cluster. This statement is correct. The biclusters attribute contains information about which genes and samples are grouped together in each bicluster. It's not just a simple count, it shows the actual membership. Incorrect. The structure of biclusters is not a simple gene cluster X sample cluster matrix. It's designed to represent the cluster memberships in a way that's determined by the algorithm's internals. I've set the algorithm to search for 5 gene clusters and 3 sample clusters. This is a parameter I provide to the SpectralBiclustering function, telling it how many clusters to look for. This is the attribute that holds the results of my biclustering analysis. It contains the information about which genes and samples belong to each bicluster that the algorithm found. This is also wrong. While the algorithm uses permutations internally, biclusters itself doesn't directly store them in a format I can easily interpret. It focuses on the cluster assignments instead. I'm using SpectralBiclustering to find groups of genes and samples that behave similarly in a gene expression dataset. It's like finding hidden communities within my data. I have a dataset with 100 genes and 50 samples. Each sample shows the expression levels of all 100 genes. Think of it as a spreadsheet with genes as rows and samples as columns. I'm telling the algorithm that I want to find 5 groups of genes and 3 groups of samples. It's like asking, can you divide these genes into 5 meaningful groups and these samples into 3? This is the output of the algorithm, the result of the biclustering. It tells me which genes belong to which of the 5 gene clusters and which samples belong to which of the 3 sample clusters. It's not just the number of clusters, but a detailed list of assignments. Nope, the shape of Biclusters won't be 5, 3. That would only tell me how many clusters there are, not which genes and samples are in each cluster. The actual shape will depend on how the algorithm organizes that membership information. Yes. BICLUSTERS shows me exactly which genes and samples belong to each of those 5 gene clusters and 3 sample clusters. It's like a detailed membership list. That's incorrect. The structure of BICLUSTERS isn't simply rows for gene clusters and columns for sample clusters. It's a more complex structure designed to represent the gene and sample cluster memberships. I'm working with a dataset that describes the activity of 100 genes across 50 samples. This is typical data in gene expression analysis. I'm using a special technique called SpectralBiclustering. The 5, 3 tells me I'm looking for 5 groups of genes and 3 groups of samples that behave similarly. It's like finding mini-clusters within the bigger dataset. This means I'm applying the SpectralBiclustering algorithm to my data. This step crunches the numbers to find those gene and sample clusters. Think of this like training a machine learning model. This is the result of my analysis. It holds the information about which genes and samples belong to each of the 5 gene clusters and 3 sample clusters. I'll get a more structured way of organizing my genes and samples. This is incorrect. The shape of biclusters underscore won't simply be 5, 3. That would only represent the number of clusters, not which genes and samples belong to them. It's a more complex structure. Think of it like a detailed membership list, not just the total head count. This is the correct answer. The biclusters underscore attribute gives me a way to see which genes and samples are grouped together. It gives me the specific membership for each gene and sample in each bicluster. It's the actual results of biclustering. Nope, this is wrong. The structure of biclusters underscore isn't a simple gene by sample matrix. The organization is optimized to indicate bicluster membership. Think of a more complex organization to show how the genes and samples group up. We're exploring how scikit-learn's SpectralBiclustering algorithm works, specifically focusing on what its BICLUSTERS attribute tells us after the algorithm finds clusters in data. It's like figuring out the secret code that tells us which data points belong together in the groups the algorithm found. I'm working with gene expression data. Imagine a spreadsheet with 100 rows, genes, and 50 columns, samples. Each cell contains a measurement showing how much a specific gene is expressed in a particular sample. The goal is to find groups of genes that behave similarly across samples, and also groups of samples that show similar gene expression patterns. This is the key attribute after we run the SpectralBiclustering algorithm. BICLUSTERS holds the answer to which genes and samples belong in which cluster. It is like a decoder ring that explains which rows and columns are grouped together based on similar patterns in the data. I'm using the SpectralBiclustering algorithm and I tell it to find 5 gene clusters and 3 sample clusters. It's like telling a detective to find 5 gangs of genes and 3 groups of samples that are acting suspiciously similar. This statement is correct. BICLUSTERS doesn't just tell you how many clusters there are. It tells you which data points, genes and samples, are part of each cluster. It's like a detailed map showing precisely which genes and samples belong to each of the 5 gene clusters and 3 sample clusters. This is wrong. The shape of BICLUSTERS won't simply be 5, 3. That just gives the number of clusters, it doesn't explain the actual membership. The shape of BICLUSTERS will depend on how the algorithm internally represents the assignment of data points to clusters. It could be a much more complex structure. This is also incorrect. While the algorithm uses permutations, rearrangements, internally, the final result in BICLUSTERS won't be those raw permutations. Instead, BICLUSTERS gives a more user-friendly representation of which genes and samples end up together in each cluster. This statement is incorrect. The organization of information within BICLUSTERS isn't this simple. It's not a simple matrix of gene clusters versus sample clusters. The structure is designed to represent cluster membership in a way that might be more complicated than a simple matrix. I'm analyzing the BICLUSTERS attribute, which holds information about the clusters found by the SpectralBiclustering algorithm. It's crucial to understand what this attribute contains to interpret the results. We're working with a gene expression dataset, Think of it as a spreadsheet. It has 100 rows, genes, and 50 columns, samples. Each cell shows the expression level of a particular gene in a particular sample. We'll apply biclustering to find groups of genes and samples with similar expression patterns. I'm setting the number of clusters to find. NCLUSTERS equals 5, 3, means I'm looking for 5 gene clusters and 3 sample clusters. That is, I expect the algorithm to identify 5 groups of genes with similar behavior and 3 groups of samples. I'm using a specific algorithm called SpectralBiclustering to perform the clustering. This algorithm uses spectral methods, based on eigenvalues and eigenvectors of matrices, to find coherent patterns of genes and samples. It's a sophisticated method that's good at finding overlapping clusters. This is the output of the SpectralBiclustering algorithm. It holds the information about which genes and samples belong to which clusters. It's not just a simple count of clusters, it gives details about membership. This statement is incorrect. The shape of BICLUSTERS doesn't directly reflect the number of gene and sample clusters. BICLUSTERS provides more detailed information than just the number of clusters, indicating which data points belong to each cluster. Incorrect. While the algorithm uses permutations internally to optimize the biclustering, the BICLUSTERS attribute doesn't explicitly store these permutations in a way that's easily interpretable. It focuses on cluster membership. Correct. BICLUSTERS contains the information about which genes and samples belong to each bicluster. The exact format is implementation specific, but the core purpose is cluster membership representation. Incorrect. The structure of BICLUSTERS isn't as simple as rows representing gene clusters and columns representing sample clusters. It's designed to show bicluster membership in a more complex way than that simple structure. This is the main question of the quiz. I need to evaluate each statement, A, B, C, and D, to determine their correctness based on my understanding of the BICLUSTERS attribute within the context of spectral biclustering.